Hello everyone, welcome again. How are you? I think now you are ready for our new topic, which is calling interpolation. I hope everything is good for you. Now I will start to teach you interpolation subject. Okay, this is an important class actually for engineers because guys, many experimental studies are examined in the engineering field, and so to interpolate to do any estimation in your data set, you should use interpolation. We have also the techniques are calling extrapolation. Do not confuse with interpolation and extrapolation, guys. Interpolation means that you are trying to estimate the value which is consisting in your domain, in your data set, which is not examined, for instance, in your experiment. Extrapolation means that you will try to, by using your data set, you will try to find out a value which is the value of a point which is outside of your domain. Domain I'm talking is domain means that guys data set. You can say that. Okay. So let us discuss what does interpolation mean on a graph. Okay, this should be better because further understanding as I know. Okay, for instance, guys, on a graph, I showed here two things. One of them is green line. You can see here the green curve. Okay. The second one is the points, red points. Okay. For instance, if you are conducting an experiment, guys, you are getting these red points. Okay. You are getting here some values corresponding to, for instance, you have here some x domain, the value corresponding to y domain. This is an ordered pair x1 and y1 or x0 and comma y0. This is giving you a point. Then this is your second experiment for your expression. For instance, at the point x1, you are getting y1. Let us assume here we are measuring the speed of a car, okay, over the time. For instance, at the time is, for instance, we are considering here car is on its way, okay, and we have starting to measure its speed at the point, for instance, at time 1 minute. Okay, 1 minute later, we are trying to estimate or measuring its speed. So 1 minute later, it gives you the speed as in that form, like y1. Let us assume it is y1. And then after 1 minute later, I mean t equals to 2 minutes later, then you are getting here its speed is now slow down. Then again increase up, up, down, like this one. So we are considering in mathematics, guys, you have here some points by an experiment, and if you want to measure here a point which is inside your domain, for instance, I'm having here T3 and T4, I want to estimate here T, for instance, instead of 3 minutes or 4 minutes later, I wish to learn here what about between 3 minutes later and 4 minutes later, the between of these time interval, I wish to learn what is the speed of this car. Okay, so it means that this is referring us interpolation to estimate that point. Of course, you didn't measure it in your experiment, but you can, of course, to estimate what is the value of that point. So in mathematics, I'm trying to teach you, okay, for your understanding actually. I wish to give here an example for in your fields as an instance for you. But in mathematics, guys, does not matter what you call here in the x-axis or y-axis. We don't care about them. The mathematics says us, okay, we have some values x component, which is corresponding some y component, and then we are trying to estimate this value. I know here my x point, and its corresponding x point. Again, I know what is the x point according to that value, but I don't know, this is also known, but I don't know what about the corresponding y point. Okay, so this is our main job here, is to create here, estimate this value. Okay, for estimation, to do this actually, you should consider here, okay, I don't know, I didn't measure it, but how can I find out this estimation? So to do this, you should use some functions, okay, or some polynomials, I don't know, so which fits your data. So your main job, first of all, guys, to discuss what is this curve. Okay, I mean the green line shows you here what is this curve which I am considering here my fitting my points. Do not forget this one. You have here some points xk and corresponding yk, which is coming from the conducted experiment. Okay, so let us try to see what does interpolation mean as in the definitions and exercises. Okay, I wrote here everything as you know. So I wish to give here three subjects, three actually subsections, subtopics for us here. To learn here the interpolation in details. But do not forget, guys, in the literature, we have a lot of interpolation techniques. And we can also expand our knowledge by considering here these techniques are also like a basis for our extension. Okay, one more thing I want to explain here. I know it is not only an undergraduate case, or it is not only used in it is not only used in the experimental studies. Later, guys, you will also see, okay, it not only that one, but it also uses is used also in the differential equation solution, especially partial differential equation solution. So guys, today it is like a basis, okay? Please try to understand these things in details. Later, because if you want to continue in your graduate education, or does not matter, if you want to do here any the progress case in your education, you will see in all engineering fields, because benefits from finite element, finite difference, and finite volume cases. Does not only the finite blah blah methods we have, but also we have here the different collocation cases, okay? I know you didn't understand what I mean here, but please try to see that all these interpolation techniques will be used later for solving all these differential equation case. Okay, we can also benefit from these topics also. Okay, it is only a culture for you. Now I will continue with our main job. Okay, so you will see here, first of all, guys, we will start with Lagrange interpolation, which is a basis case in the interpolation subject. And I'm giving here the Lagrange interpolation, but later maybe we can also continue with the spline case. So the linear spline takes the basis as Lagrange interpolation. But also we also know that here, not only that one, guys, we will also see the cubic splines, for instance, or any other spline techniques can also use here the Lagrange interpolation as its basis. So after completing the Lagrange interpolation, we will continue with Newton divided difference interpolation technique. So do not forget, if we'll see here the Newton As you know, his name arises in a method. It means that now you will see here the derivatives, okay? Do not forget it. And then we will see the least square approximation, which is also known in statistics as the regression analysis. Among the engineers, it is also called as regression analysis. But now you will see all the details of the least square approximation, I mean regression analysis. So do not forget, guys, in mathematics, we don't use only least square approximation in statistics or numerical methods. It is also used in artificial intelligence. The regression estimation, we have here in machine learning two cases, classification or regression. This regression in the machine learning or artificial intelligence, it takes as its basis as the least square approximation. Now you will learn what does it mean, okay? Let us continue with Lagrange interpolation. Okay, first of all, as a definition, let us read the definition, then we will discuss something which are important for us, okay? If x0, x1, blah blah, xn are n plus 1 distinct numbers and f is a function whose value is given at these numbers, then a unique polynomial px of degree at most n exists with f of xk will be equal to pxk for each k is starting with 0, 1, 2 and up to n, where this px, this is your polynomial, will be obtained by this using this summation formula, where this lk is obtained by the production formula. I know this definition is very closed. It's very compact and complicated for you, I know, but we will discuss on an exercise that you will understand what I mean. But previously, I want to give here, first of all, what is here x0, x1, and xn, because in our videos, in our lectures, from now on, we generally use the abbreviation to denote this data set as nodes. So you will understand what I mean as when I'm saying nodes. Okay, guys, these data set points, it is like let us again consider our previous assumption, like our experiment we are creating here, we are measuring a speed of a car over the time. So these time values that you are measuring the speed of this car gives you x0, x1, t0, t1, t2, like this one, okay? These are called as nodes in the literature, or maybe we can also use as nodes. So they are the same thing. They denote us the same thing, okay? If I'm saying nodes, then I mean x0, x1, and blah, 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 xn. When I'm saying nodes, then I mean here x1, x2, x0, and so these points, okay? So we are saying n1, n plus 1 distinct points. This point is so important. The number of points are n plus 1 because, guys, we are starting with 0 and up to getting n. So these measurements, these points, says us both of them are included. So starting with 0 and up to getting n, it means that n plus 1 times I repeat myself. So this, I repeat myself, I'm saying the experiment, okay? It is repeated n plus 1 times, I mean. But you know that distinct points, of course, we are talking about. Okay. On the other hand, we have here some function f of x, which is our exact function. Let me write here because it is so important for us. This is exact function, okay? F of x is exact, where we are saying the exact one is f of x, and your main purpose is to describe what is this f of x value. So, and we know that here is my px will be my approximation for my f of x value. But the thing here is that, guys, you need to know it. We are considering here my p, which is my approximation, will give the same results at my nodes, okay, with my exact one. So this is so important. So I wish to give here, you need to know these things. This is so important because for us. Okay, on the other hand, you need to know that, okay, I'm writing here unique polynomial, but of the degree at most n. So at most n means that at most n, if I'm saying at most n, so it means that, guys, it can be maybe degree 1, degree 2, degree 4, degree 5, but at most n. From n plus 1 distinct points, you can find out at most n degree polynomial. One is missing then, okay? Do not forget it. In Lagrange interpolation, this is the keyword for obtaining here the degree of the polynomial. Okay, here we are having a closed formula. I know you don't understand here how we apply it, but in the example, when you are seeing on an example, on an exercise, it should be more clear for you, okay? But you need to know that these LK are said to be weights. These are calling weights of the Lagrange interpolation. Okay, guys. Now, let's have a break at that point. Then we will continue with the error estimation. After these error estimation notes, then we will discuss how we apply Lagrange interpolation to an exercise. See you in the next video.